Hello everyone. So today we're going to solve this problem, state space representation to transfer function. So this is the example number 1. So don't be afraid with this topic because this is just an easy problem and also an easy concept, because all you have to do is to follow the steps, and then after that we're done. Plus, this is also a special video because as you can see, I'm going to make it much more easier with the help of MATLAB code for checking and also for guiding in our solving process. Okay, so without further ado, let's start with this example. Okay, so as you can see in this example, or in this topic and concept, all you have to do is to do this 4 simple steps. The first one would be the identification of variable, this one, the third, and then the fourth. Okay, so you're just going to use formula in order to get the transfer function, or to convert this into a transfer function. So just follow along.
All right, I have a plan, or at least the beginnings of one. It's pretty simple. We draw them in, pin them down, get what we need. Definitely don't want to dance with this guy. We just want the gauntlet. Are you yawning in the middle of this while I'm breaking it down? Huh? Did you hear what I said?
Stop listening after you said we need a plan.
And then we're going to be able to solve this. Okay, so let's start with number 1. Okay, so there are 4 variables here. Okay, so the first one would be this. Okay, so this is RA. The third, the RB, would be this one, and lastly this one. That's our C. Okay, so and then we're done with the identification variable. In programming language, and also if you use certain function in MATLAB like SSTF, you will encounter with this variable. But in this example, we do not have to worry about this variable. It has a value of 0. Okay, so we're done with the first step. So the second step would be this one. Okay, so Si minus A is just the identity matrix multiplied by S. I know you're familiar with the identity matrix, so I'm not going to elaborate much about this, but if you do that, it would be just this one, because the identity matrix is just 1, and then we have S here, so we multiply it. Okay, the purpose of this 1, because we're going to subtract it with this one, and as you can see, this is a 2 by 2 matrix, and it should also be subtracted using a 2 by 2 matrix as well. Okay, so after this, what we're going to do now is we're going to execute it. I know you're all familiar with this one. So this one is for that one, this one, then this one. Okay, the result of that would be S plus 5, because you subtracted this one. So S, and then multiplied by negative would become positive. So S plus 5. Okay, so now we're done with the second step. So far, so good. So now, as promised, I have a MATLAB code to guide us in our journey in solving this problem. So this is my MATLAB code. Okay, so basically what this code does is just what we're doing here. It's just that it is programmed in the MATLAB syntax. Okay, so again, the first step would be the identification of variables. I just input it here. Also be aware of the syntax. Okay, this one. And as you can see, all you have to do is input this number into the code. Okay, and then if you run this, okay, so now we're going to switch into this view. Okay, so this is our identity matrix, and then if you do what we did on the step number 2, would be this one. If you check it here, it's the same. S plus 5. Okay, and now we're going to the step 3. Okay, so this is step 3. What is happening here would be just like this. What we're going to do here is we're just going to cancel this. Ta-da! Just kidding.
You serious?
Okay. So, what we're going to do here is we have to find the adjoint of this one and then the determinant. And it's just the same with the inverse of this one. Okay? So now, let's tackle or solve this numerator first and then the denominator. Okay. So, with the process of adjoint, I'm going to use the concept of cofactor. Personally, this has the most efficient and also easy to follow process, cofactor. Now, if you're not familiar with the cofactor, I have this basic one. Okay, and then we're going to focus on this one. So basically, what does cofactor do is that, for example, we have this kind of matrix and we have to find the A factor of A11. Basically, this is the A11 cofactor. Basically, what we're going to do here is just we have to cover this one. So the highlighted would be ignored. And then we have to pick this one. A22 for this one. A23 for this one. A32 for this one. And then, right? And then the last step that we should not forget, this is one of the most critical, would be this step. Okay? Okay, so you can pause the video and then apply the same thing what we did for this one. Okay, and then this one, and then this one, and this. I'm assuming you give it a go. So now we're familiar with the cofactor. Okay. By the way, after you've done that, we're going to find the determinant and then transpose. But again, with just 2 by 2, we don't have to find the determinant and then transpose that. Okay? Okay. So, what will happen here is just going to find the cofactor. Okay? Okay. So now, let's find the cofactor of that. So, assuming we cover this one, because we're looking for the cofactor of this one. So this one would be affected, and then this one. Therefore, the cofactor would be just s plus 1. Okay, so for this one, just screen, we're looking for the cofactor of this one. So therefore, horizontally this is affected, and then vertically this is also. So 0. So the same concept with this one, and then this one. So with that being said, if we're dealing with 3 by 3, we're going to find the determinant. Okay, so now what we're going to do next is that we're going to use or to apply this step. So plus minus. Sorry, you're wrong. It should be minus, then plus.
Stop it. Get some help.
So basically, it does not do anything. So I'm just going to leave it that way. But don't forget that if you're dealing with 3 by 3 and also with 2 by 2, it just that happened that those steps is we're not gonna affect our matrix. Okay, so just to keep it simple and clean. Next would be transpose. You have to transpose when looking for the cofactor. Okay, so basically the transpose of matrix is just a flipped version of the original matrix. We can transpose a matrix by switching its rows with its column. Okay, and with that being said, if you switch this into row into column, it would become s plus 1, and then this one would be swapped into this to 0. Okay, so now would be this one, this row. So we're going to put it here. So 0, and then same, s plus 5. Okay, so this is a transpose.
That's a compliment. Don't forget, I'm half human, so that 50% of me that's stupid, that's 100% you.
Your math is blowing my mind.
Excuse me?
Okay, so that's the important step. Even though I already knew that it does not have an effect, I would like to emphasize that those two steps is critical. And with that being said, let's go and find the denominator, this one, or the delta. Looking for the delta in 2 by 2 is just an easy step. But before that, let's check our result with the MATLAB code. Okay, so the adjoint of si minus a would be this one. Okay, so as you can see, it shows clearly that we're on the right track. So that's, it's cool to have this picture. Okay, now we're going to find the delta of 2 by 2. I know you already know this, so this would be just quick. So the delta of si minus a would be this one. So s plus 5, s plus 1 multiply. So I'm not gonna expand this because it is much easier this way. And now we're just going to rewrite it this way. Also, you could also check it using our code. So as you can see, s plus 1, s plus 5. Okay? Okay. Rewriting this one would result into okay, so the numerator would be this one and the denominator would be this. So that's why in my MATLAB code, this one is numerator, and then I decided to have a name of determinant. Okay. With that being said, we're done with our step 3. Okay. So now, we deserve a clap from here.
Nice.
But not yet a drum roll because we're not finished. What we're going to do next is we're going to use the formula. This is our fourth step. So TF, or the transfer function, is equal to C, which is just 0. Okay. So we're going to deal with this first, and then after that deal with this one. A quick caveat, while I'm making this program, I have an error with this one. If you try to, swap the place or interchange this, the MATLAB will give you an error code due to the fact that this is not equal. Okay, so be aware of that. Okay, and with that being said, let's go and solve. So our C would be this one. Okay, so what we're going to do here is matrix multiplication. Again, what is matrix multiplication? I'm just again going to use this as our example. So as you can see, what we did here is just this one. Okay. After that, we add this one. Then you add this one. Okay. And then to separate. And then after that, this one, and then this one. So, and then you can pause the video and give it a try on this third column. Okay, so now we're going to apply this principle on 2 by 2. With that being said, our first step would be draw the line. Then, beautiful. Okay, now if we do that, the answer would become okay. So as you can see, I just multiplied this one and then this one. So since it has 0, so it simplified into this structure. Again, we're going also to use the MATLAB code to verify. So meaning C multiplied by our numerator. So it would be 3s plus 1, and the MATLAB already distributed it, but it's just the same, and this one. Okay, again, this is just the numerator. Okay, and now we're going to multiply now this one by the letter B. Okay, and then I'm just going to copy it. Okay, so we're going to multiply this. Actually, we're just dealing with the top. So, same process what we did or with this one. Okay, so same process. Okay, so if we do that, we will have this one. So this one will be just the important 3 times 2 would be 9 s plus 1. We deserve now a drum roll. Okay. So, if we go back again to our MATLAB code, we have this b, which is 9s plus 1. It's just distributed. And then the transfer function is this. Cool, huh?
Oh my god! Wow! Oh my god!
So it's great that we have this MATLAB code to check our process. And again, just to summarize what we did is, feel free to look at it. And then just remember this one. See? Okay. So identify the variable, you subtract it, find the inverse, which is this formula, and then we insert the formula. And that's it. We're done, and this is our final answer. I hope you learned a lot.